Okay, welcome to this session. While loops, introduction. In Python, for loops are not the only type of loops we can use. Another type of loop is called a while loop and is a form of indefinite iteration. A while loop performs a set of instructions as long as a given condition is true. The structure follows this pattern. While, then we'll have some conditional statement, then a colon, and then the action on the next line. So let's notice just briefly how this is different from the other loop. Before we had for temporary variable in, and then the name of the collection. Similarly, here we go straight into the keyword. So for was a keyword, wasn't it? For, but this time the first keyword is while, and there is only one keyword, it's while. So while, and then you put the conditional statement, the thing that has to hold, the condition, maybe it doesn't hold. While, and then colon, do this. So then on the next line you put the thing you want to be done. Let's examine this example, where we print the integers 0 through 3. Remember, the word through means it goes through them. It's like the skewer and a kebab. It includes 0, it includes 3, it goes through them. It's not like 0 to 3 where we don't actually include 3, just to be clear. It's through, skewer. Count equals 1. So we've assigned, remember the direction, we start at the left. The important things go at the left in Python, and then the soldiers that get moved around and assigned to different units, they go on the right hand side. So just to be clear, what we're doing here is we're assigning 0 to count. We're not assigning count to 0. There's a direction here, okay? So we're saying 0, report to count. We've set a value for count. And now we can see the loop here. So we begin while, that's our keyword while, count is less than or equal to 3, colon, and then the loop, the action. Hash loop body, print function count plus equals sign 1. So remember, this is called the, is it the add equals? Yeah. So it's a little bit like a sword, and it's as if the sword is stabbing the 1, making it part of the pile. The same way you might have one of those metal spikes and you would stab a ticket or a receipt onto it, and then you'd have a big pile of receipts on it, or whatever. So we're stabbing onto the 1 so that 1 is added to count. So let's step back and think, what's this doing overall? While this variable count, because that's the name of the thing here, so while this variable is less than or equal to 3, so it could be 3, it could be 2, it could be 1, and if it's less than or equal to 3, and then this is the action, they've just put a comment here to say, this is what we're going to do, we're going to print count. Okay, yeah, so we're going to print it. So as long as it's 3, we're going to print it. We're going to print the value. If it's 2, we're going to print it. If it's 1, we're going to print it. As long as it's less than or equal to 3, print count. But then I'm not sure why. I understand what this line is doing in itself. It's saying increment. Is that right? Increment the value of count by 1. But is that the rule then? We're allowed to the rules let us just use one line for one action, another line for another action. So print count and then count plus add equals 1. So while count is less than or equal to 3, what we're going to do is print the value and then increase whatever the value was by 1. So you can see this first line is saying we're assigning it a value of 0. It's not 1, it's not 2, it is 0. That's what that line's doing. So this while loop is saying, well, if it is less than or equal to 3, and it is, it's 0, we're going to print the value and increment it. So you've got to imagine it going tick, 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 1, and now it's 1. It's not 0 anymore, it's 1. And now you can see that that's kind of a reason that there's been a change of values. So the idea is we go through the loop again. And that's I think that's a bit of a strange idea, because you might think, well, the loop is done. The loop, how do we think about this in time? Because you might think, well, the count was less than 1, less than 3, less than or equals 3, it was 0. So we've done the action, throw away the loop. Throw away this now. We've done it now. But there's this. I think what's confusing is the idea that there's something different about these lines, right? This line is saying print count. Okay, so that's a kind of, we're not changing the world. We're just reporting on the state of affairs. It's a bit like saying to someone, look at this crowd of people. Tell me how many red hats you can see. And they say there are 7, nothing changes. They say there are 10, we're not going and doing anything. So this is very different, this line. This is saying take count, which is just the name of this variable, this container for a value. Could be chicken, ignore what it says. Take that and change it. Add 1 to it, whatever it is. So that's completely different. That's like me saying, go and, steal somebody's red hat and then run back to me. And so there's something sort of strange about that. Like this is obviously an action, because that's changing things, whereas print isn't an action. And I think that just under the surface makes it seem a bit funny, because the way we explain it is we say this is an action, and so when we looked at for in loops, the other type of loop, the only I think I'm right in saying the only example of an action that we saw there was printing, right? So we're happy with the idea as a student. We're happy with the idea that printing is a sort of good example of an action. In fact, that's the only action we've seen so far. But count is interesting because well, what I'm wondering is the fact that count changed the value, is that like the trigger for going through the loop again? You might say, no, it's not the trigger for the loop going again. The loop repeats itself automatically. The reason for it repeating is sort of within itself. It doesn't rely on what you've written for the action. So you might say, no, it's not the trigger. Well, my next question is, well, how frequently does it repeat this loop? Does it check back? Does it run every 1 second? Does it run every 10 seconds? Does it run every microsecond? There must be some value, mustn't there? So why do I think that? Why do I think there must be some value? Well, because there must. Things happen in time. Things happen in time. I'm sorry, there's no more basic way of putting it. If you say the loop repeats, so it does it one time, then it does it another time, then what you're saying is you have at least two distinct events occurring in time. So you must then be able to ask, well, how quickly does it do it? Does it do the loop once for the first 10 milliseconds and then tries again? There must be an answer, must there not? Unless you want to say, well, it does the second run as soon as the first run is finished. So as soon as it's gone, while count is less than 3, so check if count is less than 3, print count and make count bigger than 1, and now we're finished, that is the trigger for doing the loop again. So maybe you do want to say that the first loop finishing is the trigger for the second loop finishing. Okay. Look, I mean, here's one thought. that you might have. So if we copy that code, so the thought you might have is this. So I have a question about loops in Python. Take this example. And so here's my question. Is it true that the trigger for the second run of the loop, I'm going to call it a run of the loop, is the completion of the first run of the loop? Yes, you're correct. The trigger for the second run of the loop is indeed the completion of the previous run of the loop. To explain further, the while loop in Python follows this process. Evaluate the condition, count, the count variable being less than or equal to 3 in this case. If the condition is true, the loop executes the body, which is the code inside the loop. Once the body is executed, the control moves to the next step after the body. In this case, count is incremented by 1. The variable count is increased. After the body completes, the condition is re-evaluated to check if the loop should continue. The second iteration of the loop happens only after the first iteration has completed its body and the control has moved back to re-evaluate the condition. Yes, that makes sense. Otherwise, we might conceive of the loop running a second time while the first sort of loop is still running. Does that make sense? Yes, that makes perfect sense. You're right to think that if the loop ran a second time while the first iteration was still executing, it could lead to confusing behavior. But there's a reason that doesn't happen. In Python and many programming languages, loops work sequentially, meaning one iteration completes entirely before the next one starts. Okay, I mean, that's not an explanation, that's just stating the fact once again, but fine. And they point out some of the negative consequences that would occur if that wasn't the case, if it wasn't sequential. Right? If the loop tried to run multiple iterations at once, it would lead to several problems. Since the loop uses and modifies variables, running multiple iterations simultaneously could result in incorrect or unpredictable results. For instance, go on, one iteration might increment count while another one is still using the old value. Exactly. If the loop were to run in parallel, it could potentially cause conflicts over system resources, which could result in crashes or inconsistent behavior. Yeah, so there's a person might have this thought. So I think one reason you might be confused by this is you might think the loop is problematic because it is because it has no integrity. I don't know the correct way to express this. It's a paradox. It is self-referential. Anyhow, self-referential. None of those descriptions quite work. Anyhow, the thought is that if the iterations, the runs of the loop happen in quick succession, then the value of count will quickly be increased beyond such that the value is greater than 3. And what this means, so I'll just say the reason it will do that is because, so after all, the action specified in the loop is the incrementing of the value, right? However, this is the problem. If the value is, if the value of the variable is greater than 3, then the variable is outside the scope of the loop. Therefore, the loop should not be applied at all to the variable. So the thought is that the application of the loop to the variable causes the variable to be beyond the application of the loop. After all, values greater than 3 are beyond the application, beyond the scope of the loop and its application. So the thought is that the loop has a sort of self-undermining property, right? Somewhat similar to the famous statement in philosophy, is it Russell's paradox? This statement is true. What is it? This statement is false. If it's true, it's paradoxical. If it's true that this statement is false, so this very statement is false. Well, if it is false, then it's not actually false and it's true. So look, there's two possibilities. Either it's true or it's false. Now, if it's true that this very statement is false, then that means that it's not true. So you see, every possibility is problematic. It's problematic if we say it's true because, well, then we turn and look at the content of the statement, and that reveals that the statement's content is about the truth value, and it says the truth value is false. So it's self-referential. Not all statements are self-referential. The statement could be, Rome is the capital of Italy. If that was true, that would be fine. Because we look at the content and it's about Rome and its position and it is within Italy and it is the capital. So that's fine. But if we say this very statement is false, it happens to be that the content is about that statement. So we say, okay, that's true, and then we go and look at the statement. Oh, it says that it asserts that the statement itself is false. Well, that means it can't be true. Okay, so that's paradox. Does this thought make sense? Okay, so yes, your thought makes sense, and you're definitely onto something interesting. You're exploring an idea that touches on the concept of self-reference, or what might seem like a paradox in a loop's behaviour. So let's break down the idea and clarify it. The loop and the incrementing of counts. The loop you're referring to, so its count is set at 0, and then we have while count is less than or equal to, so less than or equal to, so the equals comes after, less than or equal to 3, print count, and we want count to be incremented by 1. The core of the idea you're discussing is based on the fact that the loop depends on the variable count staying within the bounds, being less than 3 or 3 itself. It does depend on that. The paradox-like feeling arises because you see two things happening in parallel. 1, the condition checks if count is indeed less than or equal to 3. And 2, the value of count is being incremented. Here's the tension. If count starts at 0 and increases, it will eventually exceed 3. But once count exceeds 3, the loop's condition will no longer be true and the loop will stop. It almost feels like there's a self-undermining property in the loop. While the loop is trying to increment count, the very act of incrementing causes the condition to eventually fail, thus preventing further iterations. Is this a paradox? Your description does indeed evoke the paradoxical nature of the situation. The loop is trying to increment count, but in doing so it forces count to exceed the threshold that keeps the loop running. This might remind you of certain self-referential paradoxes in philosophy and logic, such as the liar paradox. That's its name, the liar paradox. In a way, your loop condition behaves similarly to this kind of paradox in this way. The loop wants to run, because the condition is initially true. Count, the variable count, is less than or equal to 3. But every time it runs, it increases the value of count. Once count exceeds 3, the condition fails and the loop must stop, rendering the loop ineffective or undermining its own progress after a few iterations. However, calling this a paradox is a bit of a stretch, because there's no logical contradiction at play in the code. It's more of a situation where a process, which is the loop, naturally stops progressing when the condition is no longer met. A better term, self-limiting. Rather than describing the loop as paradoxical or self-referential, it might be better to describe the loop as self-limiting. The loop's action of incrementing count eventually causes the condition to fail, which limits further iterations. This self-limiting nature is part of why the loop ends. It's designed to stop once the condition is no longer true. What makes the thought interesting? What makes this thought interesting is the awareness of how the loop operates. The very action that moves count toward the end goal is the action that causes the loop to terminate. In that sense, the loop does something that effectively disqualifies the variable from being in the scope of the loop's condition. This dynamic creates a kind of feedback loop, or self-regulation, where the loop's own behaviour determines when it must stop. And in a very real sense, the behaviour of the loop is inherently tied to the variable's changes. This gives it a flavour of self-undermining, even if it's not strictly a paradox in the formal logical sense. But suppose we removed the line that contained the print function. There is now a sense in which nothing observably happens. Okay. So no, that's not my point. So, no. But suppose we remove the line that contained the print function. I say this so that we remove sort of any observable output that needs to be sort of generated. And let's suppose that one line decrements the value of the variable, right? Takes it down. So in other words, so this means we have our one line. So we have our one line that increases the value by 1, and another line that decrements it by 1. Now, as you and I know, adding 1 and then removing 1 is equivalent to doing nothing. Now, is there any sense in which the loop knows this? Because if there is, then the loop can just maintain the value of the variable. Or is it instead the case that the loop does not know this and really does repeatedly add and remove ones? Does repeatedly add 1 and then remove 1 continuously. And if it does this get cashed out in anything observable? Is there some, microscopic activity which we could conceivably, even if not practically, observe in the computer chip, which would indicate that this loop is repeatedly adding 1 and then removing 1, like some poor robot condemned to picking something up and then placing it down again until for eternity. That's an intriguing scenario. You're delving into a very interesting philosophical and computational idea about whether a loop knows that adding and subtracting the same value results in no net change, and whether this behaviour could have observable effects. Now, when you say it's a very interesting philosophical idea, usually when people say that, they mean it doesn't really matter, and it's deep, and it's stupid, basically. But I really mean this, because I'm trying to understand it. I think this is the core of... I think it's a basic question. I don't think it's philosophical. Let's break it down. And I'm serious about it. It's not just a sort of parlour game, let's play a Sudoku, doesn't matter kind of thing. So you have a loop that increments a variable by 1, then immediately decrements it. Mathematically, this seems equivalent to doing nothing, because we leave it unchanged. And the question is whether the loop knows this. No, in scare quotes. And if it does not, does it repeatedly add and remove 1? Or if the system would display any observable effects of this repeated process. So, let's take some of the issues one by one. Does the loop know that the operations cancel each other out? No, the loop doesn't know in the way that a human does. In a computer, the loop is simply a series of instructions: increment the variable and then decrement it. There is no built-in awareness or reasoning process that allows the loop to realise that these operations cancel out. The computer executes each operation as instructed step by step without understanding the larger implications of the calculations. Therefore, even though incrementing and then decrementing results in no net change, the program doesn't optimize itself or skip these steps based on an understanding of the result. It simply executes the instructions given. Is the loop repeatedly adding and removing a 1? Yes, the loop does exactly that. In the absence of optimization, such as manually writing the code to skip the redundant steps, each iteration of the loop will first increment the variable by 1 and then immediately decrement it by 1. This results in no observable change in the value of the variable from one iteration to the next. Would this have any observable effects? Theoretically, yes, there would be observable effects at a very low level, even if practically we don't notice them. The actions of incrementing and decrementing a variable take time and computational resources. Each operation involves the processor performing several micro-operations, like fetching the instruction and updating the variable in memory. Even though the end result is that the value of the variable does not change, the computer still performs these operations. These operations involve the CPU executing machine code, accessing memory, and performing arithmetic, each of which takes time and energy. In fact, even if the value of count doesn't change, the program will use processor cycles, power, and memory bandwidth to repeatedly execute those instructions. This could be measurable in terms of CPU usage. You'd see the CPU being busy performing these redundant operations, and energy consumption. Even though no state change occurs in the variable, the computer is still consuming power to execute these operations. Okay. If you had highly sensitive equipment to observe the processor's activity, you might be able to measure the cycle counts or other micro-level activities that reflect the repeated execution of these redundant operations. Would we observe this as a robot condemned to pick something up and place it down again? In a way, yes. The analogy is quite fitting. The loop is indeed performing the same action over and over without achieving any final change in state. You could think of it as the robot constantly picking up and putting down an object without making any progress toward a meaningful end result. At the hardware level, the computer will still be executing these redundant steps, even though it leads to no visible effect on the variable. If you were able to monitor the state of the processor very closely, using special diagnostic tools or software that tracks CPU cycles, memory accesses, then you might be able to observe this repetitive work in terms of processor activity, though it's not visible in the higher level program logic or in the output. At a very fine-grained level, like on the hardware or chip level, you would see the following. The CPU would execute instructions like increment or decrement in a rapid, repetitive manner. Each operation would involve loading the value of count, incrementing it, and then decrementing it. This would involve memory reads and writes. Each increment and decrement operation takes a certain number of clock cycles, even though the final result is that the value of count stays the same. If you could measure the time it takes to perform each pair of operations, you might find that the processor is continually working, even though the program's visible state doesn't change. So the reason I ask that is, so here, so I just want to bring that back. So that's very interesting, thank you. To bring that back to what we were discussing, we were looking at this loop, and I suppose I now know that there's no sense in which the loop can sort of foresee that the variable must be moved to be for, right? So someone might believe that the loop sort of foresees that it is going to stop once the value of the count variable is 4, because 4 is not less than or equal to 3. But this belief is false, right? Right, yeah, so someone might believe that loop foresees that it's going to start once the value of count is 4, so the loop therefore just skips to the chase and makes the value of count be 4. But this belief is false. Correct? This belief is false. Am I correct in saying that? Yes, you're absolutely correct in saying that the loop does not foresee that count will reach 4 and therefore skips directly to it. It doesn't kind of compare what's in the condition to its action and say, well, I can see that I'm going to do this action and this action and this action, and that relates to the condition. And it's not like a footballer moving along a field and saying, well, instead of dribbling the ball across 10 meters, I could just kick it across the 10 meters. You know, it doesn't, and what the footballer's doing is he's saying, well, I've got this end goal, I'm here now, yes, I could use these actions, or I could just do one big action to get there. Yeah, and in the same way, a loop also has this condition part, and then there's another part, isn't it, which is the action, and as we said, the action does sort of interact with the condition, because the action can mean that eventually the condition is false and doesn't hold, right? Because remember, we say increment the count variable, bong, goes up, increment it again, goes up, increment it again, goes up, and that's like a footballer doing a little dribble. Of course, eventually we have to say, well, actually, the value of count isn't in our remit anymore. We've pushed it to 4, and we only deal with it when it's in the remit of values below 3 or 3. So you can see that the action does actually interact with the condition, and it's the same with a footballer. So he dribbles and dribbles and dribbles, and then he puts it in the goal. And then he says, well, it's not really in my remit now. I don't have to keep kicking it if it's in the goal. But I'm saying, well, is a loop a bit like a footballer? Because a footballer can reason and say, well, instead of just doing 10 steps to the goal, I'll just kick it across the 10 steps in one go and land it in the net. No, the loop does not do that. That's where the analogy breaks, okay? The idea that the loop knows it will stop and directly jumps to count equals 4 is a misunderstanding of how the loop operates. Let's break this down more clearly. What the loop does. The loop executes, just to go over one more time, the loop executes the following steps. 1, it does this condition check. CC, great phrase, condition check. So it first checks whether count is less than or equal to 3. Is that true? Is that I like to say with conditions, they're not true or false. Does it hold? And then execution of the loop body. If the condition is true, it proceeds to execute the body of the loop, which in this case is printing the value of count and incrementing count by 1. And then re-evaluation. After one iteration, the loop goes back to step 1, rechecking the condition, the condition check. Is count less than or equal to 3, with the updated value of count. Why the loop doesn't foresee the end. There's no foresight or prediction. The loop is just following a set of instructions, step by step. Each iteration is independent of the next one, in the sense that the loop does not know ahead of time what will happen at the end. It simply checks the condition, runs the body, and then checks the condition again after each increment. When the loop starts, count begins at 0 and increases by 1 each time. When count reaches 4, the condition, count is less than or equal to 3, will fail, and the loop will stop only after completing the iteration where count is 4. It does not skip to 4 early or make a prediction about when it will stop. It executes the loop step by step, updating count and checking the condition after each update. So, does the loop have the power to change the line of code which is prior to the beginning of the loop? Right? Does the loop have the power to change the line of code before it, prior to the beginning of the loop? Right? The reason I ask that is that the line which states that count equals 0 is before the loop begins. Now, if the loop can't change this line, then each iteration will be starting from the same state, namely count is equal to 0. But we know this doesn't happen, and we know that the loop builds on its progress. In other words, if the action in the body changes the value of the variable in one iteration, then in another iteration this is taken into account, So my conclusion is, yes, the loop does have the power to change the line of code prior to the loop itself. Am I reasoning properly here? You're asking a very thoughtful question, and I can see where the confusion might come from. So let's carefully analyse the situation, because the way loops work might make it seem like the loop is changing the line of code before it begins. But that's not quite what's happening, right? The roll of count equals 0 before the loop. Right? Because look, count equals 0. And so we're setting the value of count, and that is before the loop. So in your example, you have the line count has assigned to it 0 before the loop starts. This line sets the initial value of count to 0. Okay. When the loop starts, it checks the value of count, which is 0 at the beginning, and will execute the loop body as long as count is less than or equal to 3. What happens during each iteration? Go on. First iteration. The loop starts with count has assigned to it 0. The condition is true, so the body of the loop runs. The print function prints 0, because count is 0. And then we have that line which says stab count onto 1, mush them together, and so 0 is combined with what, because count is 0. So 0 is combined with 1. In other words, we're incrementing count. We're adding 1 to count. So now count has a value of 1. And that's why I say, well, does it sort of slot that into that line then and say, okay, the first line is now count is equal to 1. That's what I'm wondering. I think it seems like it does. Second iteration, the loop checks the condition again. Now count is equal to 1, right? But yeah, let's just read. Now count is equal to 1, and count is, well, 1 is less than or equal to 3, so the condition check is still returning true. So print count prints 1, and the line count plus equals 1 increments. And so notice how it points forward. It's plus equals. It's not equals plus. Sort of going forward like a streamline from left to right. The equals is more like sort of penetrating, isn't it? Plus equals 1 increments count. So now count is equal to 2. The third iteration, the loop checks the condition again. Now count is equal to 2, and count the condition, well, that's still true. The print function prints 2. The line count add equals 1 increments count. Okay, we get it. Finally, when the loop checks the condition again, count is equal to 4, and count is less than or equal to 3. Well, that's false. The loop stops. Here's the key. Well, yeah, I knew all that though. Key insight. The loop doesn't modify the code before it starts. Now let's address your key question. Can the loop modify the line before it starts? The short answer is no. The loop cannot change the code before it begins. The line count as assigned to it 0. Here's why. Go on. Here we go. The code before the loop is executed once, before the loop starts. The value of count is set to 0 just once before the loop runs. And the loop does not have the ability to modify this line or change the code before it starts running. What the loop does do is update the value of count during each iteration of the loop. Well, I knew that as well. The body of the loop modifies count, and those updates are persistent across iterations. So after the first iteration, when count becomes 1, the loop uses this updated value in the next iteration, and so on. The loop builds on its progress in the sense that the value of count is updated during each iteration and is carried over to the next iteration. But this is not the same as modifying the line before the loop starts. Well, that's not quite answered my question. If we don't if the loop doesn't modify the line which sets the value of the variable, in what sense at all does it modify the value of the variable? For surely the value of the variable is nothing but the value specified on the line of code which assigns a value to the variable. Damn you! So you've previously told me that the line which says count equals 0 is not actually modified by the loop. But I have this question. If the loop update sort of builds on its progress and updates the value of the variable, how can it not be the case that it changes the line of code where a value is assigned to the variable? Surely the assignment, surely the value of the variable is nothing but the line of code where it is assigned a value. This is fascinating. Oh, again, it's philosophical, right? And it's about really how programming and computation work. So when I say that the line count equals 0 is not modified by the loop, I mean that the actual text of the code does not change. The line count equals 0 is a statement that executes once when the program runs, and its purpose is to initialize the variable count with the value 0. After this line executes, the variable count comes into existence in memory, and from that point onward, its value can be updated independently of the line of code that originally assigned its initial value. Okay. Variables are independent of their initializers. A variable, once created, is essentially a container in memory. The line of code count equals 0, count has assigned to it 0, is like the act of placing 0 in that container at the start. The while loop then modifies the value stored in the container because it has the statement count plus that streamline equals stabbing onto the 1, the increment symbol. And this updating process does not go back and alter the original line, count equals 0. That line has already done its job. It initialized the container with the starting value. Okay, again, that line has done its job. It initialized the container with the starting value. To make an analogy, Imagine writing 0 on a whiteboard. That would be the count equals 0 statement. When you update the value, e.g. by erasing 0 and writing 1, you are changing what is on the whiteboard, but you are not altering the act of having initially written 0. The original act remains in the past. Okay, and that's what's happening with the code. So count equals 0, it's just been written there. We don't have to change what's written just to say that the loop is updating the value of the variable. It is updating the value of the variable, but we don't need to muck around with the line of code, and therefore it's false actually to say that the loop alters the line of code before it. And that makes sense, doesn't it? It would be strange if the loop can change the code which is outside of the loop and before it. What is a variable's identity? Now to your deeper philosophical point. Surely the value of the variable is nothing but the line of code where it is assigned a value. In programming, a variable's identity is more than the line of code where it was initialized. Here's why. The value of a variable is what it currently holds in memory at a given point in the program's execution. The variable's current value reflects the series of operations, like wrinkles on someone's face that have acted upon it. It's not just its initializer. The line count, that line, just one line count, has assigned to it 0. That's the origin of the variable's existence. But once the variable is created, its subsequent state depends on the code that manipulates it. Does the loop build on its progress? Yes, the loop builds on its progress by repeatedly updating the value of that count variable. But notice why this happens. This happens because, the reason it repeatedly updates that value of the variable, because the statement count incremented by 1 modifies the variable count directly in memory. The loop does not go back and re-execute or alter the line count equals 0. Instead, it works with the variable count as it exists in memory. If the value of a variable is not identical to the line where it was initialized, then the loop can update the variable without modifying that line of code. The variable's value is a dynamic property that evolves as the program executes. The line count equals 0 simply provides the initial value. What happens afterwards is determined by the rest of the program. Oh, and how personal. A philosophical parallel. Your question touches on an idea akin to the philosophy of identity and change. In programming, the variable is like a substance, literally thing under, substance. So the variable is like the thing that persists through time, but the value is like a state, a property that changes over time. The count variable exists as an entity, and its state, or value, evolves through the loop. But this evolution does not retroactively alter the origin of the variable's existence. Okay. Right, that's a satisfying end, I think. So we've studied this example. Count has assigned to it 0, and this is our first while loop. So while, just one keyword, while, and then a space. While. And then count is less than or equal to 3, colon. And we've got, this is a great example, we've got two actions. We've got a print action and a count. It's bigger than 0. Actually, one last question. Would it make a difference if I swapped the line that prints and the line that increments? Yes. Actually, it would. swapping the lines will change the behavior of the program, because the order of execution directly affects the value of the variable count when it is printed. So here's the original loop. So we print first. So that's as it is. Yeah, look here. Print, then increment it. But if you were to swap the lines so that we had count and then print, well, so the value of count would be printed before we've made that change, right? So with the original order, print first, you can see that we're kind of, it's almost like taking a photograph of something before we fix it, right? So obviously the increment line is like as we said, it's an action. That's obviously an action line, you know, compared to print. I know print, we said print was the action we were most familiar with, but still, you know, we pay photographers because they're doing something, aren't they? But still, what they're supposedly doing is just taking some sort of visual description, right? They're just going, they're not going and fiddling with things usually. So it's not really a kind of action in terms of, you know, it doesn't change things, print. The real one that we have is count, right? So in that sense, so just work with me, in that sense, count, the increment line, the increment line is more of an action than print. So originally what we're kind of doing is going, okay, take a quick photo, here we go. Take a quick photo, print it, then we'll do our little fiddling with it with the increment, right? Now I'm saying, what if we did the increment, then we printed it? Well, that means we don't actually ever take a snapshot or make a record, a print of how things were originally, right? So in other words, we wouldn't have a line where we have 0. A line where we say, okay, the value of the variable is 0. We'd just have, okay, it's 1, because we've already incremented it. It's 2, then it's 3, then it's 4. The way they've done it, print what it is, now change it, now go in and get your hands dirty. And that's better. So that means we do have a line where it's recorded that, you know, the value is 0. So the difference is in when the print statement sees the value of count relative to the increment line, the count plus equals 1. Swapping the lines does change the starting point of the printed sequence, and it will shift all the values accordingly. So it's not the case that once you do the colon, then you can kind of bungle together all the things into the loop body. It's not a bunch. It's more like a sort of ordered list. The lines are an ordered list. Okay, now we're ready to finish.